Okay, so let's move on sa ating topic for today, dynamic spectrum sharing and Open RAN. So here are the topics for today. Yan. So we will have a short background for radio access network, introduction to RAN. So ano lang tayo, no? Review lang, quick review for the RAN. Then what is spectrum? Okay, so we need to understand first what is spectrum before we understand dynamic spectrum sharing. Okay, so this is very fundamental. Especially if you really want to become a telecom engineer or an RF engineer in the future. So you need to understand this carefully. Okay. And then we'll have this Open RAN technical priorities, and then what are the use case of Open RAN in terms of the dynamic spectrum sharing. Okay, so ano to focus yung ating discussion for the day is if you can decode it, actually it's focusing on the frequency. So you will understand in this session deeper the concept of spectrum and frequency, and you will have a lot of insights, no, pagdating sa spectrum, especially here in the Philippines. And we'll end with the key learning points. Okay. So we'll start with the nationwide mobile coverage. So we'll have this radio access network. So this is strategically placed to provide wireless coverage to users within specific geographic area. Okay. Wala pala akong video. Okay. So the placement of radio access network components such yung mga cell sites, kilala natin to as cell sites, which is critical to ensure the users have reliable and consistent access to the network services. So we put different cell sites, no, sa iba't ibang part ng Pilipinas. Okay? So the main reason why we have mobile signal is because of the radio access network. And the radio access network is the infrastructure that uses electromagnetic energy to propagate in space and reach our mobile devices, no? Kaya tayo nagkakaroon ng mga signals like 2G, 3G, 4G or 4G advanced or 4G plus and 5G. Okay? So this is just a review, no? Nakita niyo itong mga slides to previously. And then the wireless telecommunication systems is composed of three major parts. As a review again. So we have the user terminals. Okay, so the user terminals, also known as the user equipment, if you're using 3G, 4G, or 5G technologies, and mobile station if you're using a 2G technology. So these are devices used by end users to connect to the radio access network, okay, of a wireless telecommunication system. Yeah, so example natin dyan, yung mga smartphones nyo, tablets or laptops with SIM card or eSIM and other mobile devices. And then we are connecting this user terminal sa RAN, sa radio access network. Okay, so the radio access network, commonly known as cell sites, okay, but technically we call it the radio access network. So the main mechanism to connect these user terminals to the radio access network is via air interface. We are using a radio frequency or an electromagnetic energy under the radio frequency spectrum, okay, band. Okay, so later on we'll dwell deeper on this air interface. Okay, so the radio access network have a different names. Meron tayong base station, okay, kapag 2G, 3G, 4G, and 5G. And then, this radio access network is connected sa core network, okay, to have this back, and then connected by a backhaul. So we have a different backhaul, no? Meron tayong microwave, fiber optic, and satellite. Okay, so ito yung ating review, no, ng wireless telecommunication system. So just to have a grasp, no, what are we going to talk about today? So today, magbo-focus tayo dito sa air interface and the radio frequency. Okay? Okay. So, pagpunta natin sa radio frequencies, we'll talk about what is spectrum. Yan. So, spectrum is the fundamental asset, okay, that provides wireless connectivity. Ito yung ginagamit ng radio access network to transmit yung ating data or signal going to going to the mobile station, and mobile station going to radio access network. It is an invisible, okay, invisible electromagnetic wave generated by radio transmitting devices. Hindi natin nakikita to because the frequency is beyond, no, the visible light, no. So ito lang yung nakikita lang nating electromagnetic energy is the visible light. So the frequency is too long, no, for us to see it. Yan. So ang nakikita nating electromagnetic energy is the visible light. And the spectrum is about frequency measured in hertz. Yan. So mamaya makita natin bakit hertz, no, ang pangalan ng ating ang unit of measurement ng frequency. And operators acquire a license, okay, to use specific frequencies for a given period of time in return for paying an annual fee. Ang tawag natin sa annual fee na yan is spectrum users fee. So later on, makikita natin ano yung spectrum users fee. And licenses usually are 10 to 10 years in duration. Okay? Ayan. Okay, so who else uses the spectrum? So maraming gumagamit ng spectrum. So it depends on which band of spectrum they are operating. Like for example, there are VLF, the very low frequency radios, like in maritime radio or navigation, the low frequency, and the AM radio also are there, and the short wave radio, the VHF television, FM radio, and then sa UHF, okay, going to the SHF, nandito yung ating mga mobile stations, no, o mga radio access network. Kasama dito yung UHF television, mobile phones, GPS, Wi-Fi, and 4G or 5G. Okay. And sa extremely high frequencies, nandiyan yung mga for radio astronomy, satellite communications. Okay. So spectrum contains all the frequencies in the universe, not only in the Philippines or in the world, but in the universe. Okay. So it's used by different types of services. Okay. Satellite, mobile TV, as I mentioned before. And spectrum goes from very low, actually there's extremely low frequencies up to extremely high frequencies. Okay. So paano discover ang electromagnetic waves? Yeah, so the discovery of electromagnetic waves. So in 1879, in 1865, there is a Scottish scientist in the field of mathematical physics. Ang pangalan niya is James Clerk Maxwell. Okay, James Clerk Maxwell. His most notable achievement was to formulate the classical theory of electromagnetic radiation. So this is the first time that he is bringing together electricity, magnetism, and light as a different manifestation of the same phenomenon. And then he also formulated ito. I know all of the ECE students who completed the electromagnetics are very familiar with these equations, the Maxwell's equations for electromagnetism. Ito yung apat, no, na kinakabisado natin last time sa electromagnetics. Okay? So the Maxwell's equations for electromagnetism also been called the second great unification in physics. Okay? Where the first one had been realized by, of course, yung kay Isaac Newton. Okay? But ito is in theory. Until dumating si isang German physicist, okay, in the name of Heinrich Rudolf Hertz. Okay, so who first conclusively, okay, proved the existence of electromagnetic waves. Yan. Na pinredict ni James Clerk Maxwell through the equations of electromagnetism. Okay, so nung panahon ni James Clerk Maxwell, hindi pa niya ma-prove yan. No? Mostly mathematical na po-prove niya yan. Pero in terms of experiments, hindi yan na-prove until dumating si Heinrich Rudolf Hertz. Okay? Kaya nung na-prove yan and then nakita yung presence ng electromagnetic waves, doon na ipangalan or na-coin yung term na frequency, yung term na hertz sa frequency. Kaya yung ating unit of measurement sa frequency ay makita nyong hertz. Okay? So, for example, you will listen sa AM radio, you can see that's around kilohertz, okay? 666 kilohertz. And then for FM, it's 102.7 megahertz, okay? And also for the cellular frequencies, gumagamit din tayo ng mga 900 megahertz, 700 megahertz, 1800 megahertz. So yung hertz na yon came from Heinrich Rudolf Hertz, a German physicist, no, na unang nag-conclude or nag-prove ng existence ng electromagnetic waves. Okay? All right. So, ano bang electromagnetic waves, no? What are waves? Okay. So, waves are traveling around you. So, this one we are very familiar, especially if you're on vacation malapit sa beach, no? So all the time, no, meron tayong mga waves na nakikita sa beach. Yan. And also light and sound is a type of waves, no. Yan. So wave is a disturbance that transfers energy at it travels through a medium. Okay, so it needs a medium, no, o itong mga wave na to. But there is a certain kind of wave that do not need a medium, no, that can travel through vacuum, and that is electromagnetic wave. It's also a disturbance. Okay, but before we go through that, let me check, no, about some different terminologies like periodic motions. Okay, so when something is periodic, sinasabi natin, ano, when something is periodic, it repeats at specific time intervals or period. So in these 3 examples, can you type in which of these examples is considered periodic in motion? Okay, periodic. Can you type in which one or which of these are considered to have a periodic motion? Remember, when something is periodic, it repeats at specific time intervals or period. Okay, so is it A, B, or C? Okay, dami sagot, ano? Okay, so CC, CB, CC. Okay, so I'll just give you the answer. So these are examples, no, ng mga periodic. Okay, so ito periodic, no, because there's a specific time interval and then paulit-ulit siya. And then also this one, yung movement, no, yung revolution ng moon around the earth is also periodic. Kaya nga meron tayong di ba? Buwanan. It's also periodic, right? Okay. Okay, now, which of the following waves naman are periodic in nature? So, tingnan natin. Which of the following waves are periodic in nature? Can you type in your answer? A, B, C, D, or E? Alin dyan ang periodic? So, nauulit, no? With a specific period, no? Okay. Okay. So the correct answers are the following. Yan. Itong periodic. Yan. So B is a periodic. D is periodic. And E is also periodic. Okay. So a wave pulse is a single disturbance, no? But a periodic wave will continually repeat at regular time intervals. Yeah. So alam na natin yung salitang periodic. Okay? Okay, next term is the oscillation. Yan, oscillation. So if you have studied trigonometry, meron tayong tawag ng mga oscillations, no? There is a sine wave, no? Yeah, so nag-ano tayo ng sine wave sa trigonometry. Okay. So an oscillation is a back and forth, no? Back and forth pattern of motion, or up and down pattern of motion, left or right. Okay? Between two states about a central position. So meron tayong central position, and then it's either moving up and down or back and forth. Okay? And then moving in between two states. Okay? So in this example again, in these three examples na nakita natin kanina, which one or which of the following had an oscillatory motion or oscillates? No? Which of the following? Is it A, B, or C? Okay, oscillation, no? Back and forth. Okay, pag nakita mo yung buwan na back and forth. Okay, it's only B, right? Because if you see the moon oscillates, may hihilo tayo na, no? Magpapalitan nyo yung werewolf back and forth, no? Okay, so it's oscillates, it's only B. Okay, so that is oscillation. Okay, now, let's combine oscillatory and periodic motion. Okay, oscillatory and periodic motion. So this one is periodic and oscillatory. Okay, so meaning there's a specific point in time that it is happening and then it's moving up and down or back and forth. Okay, but this one is periodic only. Okay, so not all periodic motions are oscillatory. Are you getting my point? Not all periodic motions are oscillatory, like this one, and like the movement ng moon sa Earth, no? Around the Earth. Okay? So, ganun din sa mga periodic waves natin. So, yung ating mga electromagnetic waves, these are periodic and oscillating wave. Okay? So, this is the point that I would like to share with you, yung mga basic and fundamental concept sa electromagnetic energy. Okay? So, these are periodic and oscillating. Okay? So, now let's move on sa wave anatomy. So, ano yung mga parts? Ano yung mga parts of a wave? Okay. So, meron tayong tinatawag na amplitude. Okay? Amplitude is the maximum displacement. Okay? Maximum displacement from waves rest point. Okay? So, ang tawag natin dyan is the amplitude. And the wavelength is the distance, no, of a one cycle or an amplitude to amplitude or throw to throw, no? Yung lowest point naman natin is tinatawag nating throw. Okay? And the highest point would be the crest. Okay? So if you're measuring crest to crest, we call it the wavelength, or throw to throw, we call it the wavelength. Simply saying it's only one cycle. This is the wavelength. And we also have a direction of travel. Okay? And almost all ECE, or electronics engineering students or physicists knows this formula, no? This lambda is equals to C over F, which lambda is the wavelength and C is the speed of light. Okay? Speed of light 3 times 10 to the 8 meter per second. And the frequency is measured in hertz. Okay? So ito yung ating frequency, no? Ito yung ating wavelength. If you will correlate it, it's just like a distance formula. When you are measuring the speed, distance, and time. Okay, so this is distance, this is the speed, and then this will become a time. So 1 over F is the period. Okay, so it's just like a distance formula. Now let's move on to frequency. Okay, so frequency, a wave's frequency, F is the number of complete wavelengths that pass a certain point in a certain amount of time. Okay, so kung gaano kabilis dumaan, no, yung isang wavelength a certain period of time. So it is most often represented in units per second. Units per second or hertz. Okay, so ito yung frequency natin. So as you can see, there are signals that have longer wavelengths than signals with higher frequency na mas maliit na wavelength. So it depends on the frequency because of the following formula, no, dito. Ibig sabihin nito, habang tumataas yung as the frequency goes up, our wavelength goes down. So this equation, this simple equation is very useful, especially sa antenna design. When you are doing an antenna design, or you are assessing what kind of frequency they are using when you just look up yung mga antennas natin sa cell sites. So why there are antennas that are small, why there are antennas that are big as a door, no? So it follows this equation, this basic equation in electromagnet, in the wave theory. Okay. Okay. So which frequency is true about wavelength and frequency? Okay, so just imagine this is a truck moving in a certain point and together with the small cars. Okay, so as we mentioned, there is an important relationship between velocity, wavelength, and the frequency. Okay, so which one is true? A wavelength and frequency are unrelated. When wavelength increases, frequency decreases. Or C, when wavelength increases, frequency increases. So which of the following statements is true? Wavelength and frequency are unrelated. When wavelength increases, frequency decreases. Or when wavelength increases, frequency increases. So anong relationship nilang dalawa? No? Yan. Yeah, so when wavelength increases, frequency decreases. Okay, so inversely proportional sila. So, alam na natin yung relationship ng wavelength and frequency. So when we map the frequency wavelength table in terms of like for example frequency and wavelength, you can see the higher the frequency, the smaller the wavelength. Okay? Because of this formula. Okay? So the higher the frequency, the smaller the wavelength. Okay? The higher the frequency, the smaller the wavelength. Okay? Do you understand this concept? Can I get a thumbs up if this concept is clear? Okay. Yan. Okay, so gaano ba ka-importante? How important is frequency or the bandwidth, no? So like for example, no, we are talking about one frequency only, right? We are talking about one frequency only. Now, if you combine different signals, if you combine different signals with different frequencies, you will form one signal with a bigger bandwidth, right? When we say bandwidth, the bandwidth is the information signal. No? Bandwidth of an information signal is a difference between the highest and the lowest frequencies contained in an information. Okay? So the bandwidth is a communication channel. Ito yung difference natin. No? So when you say difference, it is the difference of this frequency and this frequency. So if you subtract the highest frequency to the lowest frequency, you will get the bandwidth. So this example is a type of a screenshot from a spectrum analyzer. Okay. So when you look at the signals measured in the spectrum analyzer, ito is an example of a 3G signal measured in a spectrum analyzer. And then when you look at the bandwidth of this one, it shows that the bandwidth of one channel, combination of different frequencies, okay, is 5 megahertz. Okay? 5 megahertz. So minsan kasi nalilito sila, no? Sir, ano po bang pagkakaiba ng what is the difference between 900 megahertz with 5 megahertz bandwidth? Okay? So when you say about when you talk about like that, no? Like for example, meron kang 900 megahertz. Yan. So ito yung ating frequency. Yan. So if you have a 900 megahertz, okay, 900 megahertz. And then you have the center frequency, no? And then you, for example, you have 915 to 945. So the center frequency is 900 megahertz. Okay, so commonly when we talk about frequency in telecom, we call it the center frequency, no? Nag-relate as center frequency. We are using the center frequency, 900 megahertz. But in real scenario, the 900 megahertz are bandwidth, a specific bandwidth. The bandwidth is, like for example, 915 to 945. The bandwidth is how much? 30 megahertz. Okay, so when you talk about this, when you describe this signal, the signal is described as 900 megahertz with 30 megahertz bandwidth. Okay? Do you get that point? Because most of the confusion comes from that. Hindi nila ma-differentiate what is the difference between the center frequency or the frequency operating frequency and the bandwidth. No, sometimes they are saying, how come we are using 21 megahertz and it's only 20 megahertz bandwidth? Like for example, in this screenshot, no? Yeah. I'm showing to you a 700 megahertz band with 10 megahertz bandwidth. Do you understand this? You get this? I'm showing to you a signal in 700 megahertz band. Okay, so 700 megahertz band. And the bandwidth is 10 megahertz. Okay, so yung lapad no signal natin. This is 10 megahertz. So always remember that the spectrum or the frequency is just like a road. And kalsada. Okay. Kalsada. So the road is the operating frequency in which place it will take you. Okay, like for example, if you're traveling from North Luzon going to Manila, so you have the NLEX, right? The North Luzon Expressway. And the spectrum, and then we consider it as the resource important for operators. Okay. So when we talk about spectrum, we correlate it or we compare it no sa mga highways and roads. So there are different frequencies, different roads, and then there are different bandwidths. So it depends on the bandwidth of your road, kung gaano kaluwag yung kalsada mo. Okay? Like for example, if you're using 900 megahertz, okay, and then it's only have 10 megahertz of bandwidth, so malapad lang yung kalsada mo, no? Ganito lang kalapad yung kalsada mo. And then there are roads na talagang masikip, no? Okay, masikip. And then there are roads na masyado malaki, may 4 lanes tayong roads. So that can be compared sa bandwidth natin. So when we talk about spectrum or frequencies, spectrum is the key asset, okay, for mobile operators. Okay, spectrum is the key asset. Why? Because like for example, you are transmitting, no? So meron tayong kalsada, no? You want to transport a certain good or product from your company going to your customers. And how you will deliver it. Like for example, you're planting or you're producing vegetables in Baguio. How will you transfer it? No? So pwedeng via air, but most of the time it's via yung mga highways natin and then roads. So frequency is just like that. If you want to transfer data wirelessly from your radio access network going to your mobile stations or mobile equipment or subscribers, you need a spectrum. You need a frequency. You need a road. No? Now your road or your frequencies is very important because why? Because even though you have a different types of frequencies, makikita niyo mamaya, no, you will see that operators own a lot of frequencies. It depends, no? It defines how much capacity can they accommodate. Why? What do you think? Bakit importante ito? That it defines the capacity. It's just like roads, right? Or highways. The wider the roads, the wider the highways, mas marami tayong sasakyan na pwedeng may daan. And then the more vehicles that we can allow to pass through, the more data or the more people, the more products we can transport. Okay? So that's the analogy of the frequency and the roads. So the more frequency we have, okay, the more resources we can use. Okay, are you getting my point? Can I get a thumbs up for this one? Okay. And it defines how wide a coverage. It defines how wide a coverage. Meaning, it depends kung gaano kalayo yung nararating ng kalsada mo. So there are roads that are short, especially the wavelength, and there are roads that are very long. Okay? In terms of propagation, malayo yung nararating ng mga roads na yan. But there is trade-off, no? When you have a high frequency and a low frequency. Okay. So most of the high frequencies, okay, most of the high frequencies, these are the frequencies. Mamaya makita niyo, I will show you, no, kung bakit. There are frequencies that has very big bandwidth, but in terms of propagation, that is physics, no? In terms of propagation and penetration, they're very poor. Like for example, yung mga millimeter waves natin, they have a very wide bandwidth, but very short. Anong example niyan? Airport runway. You know, airport runway. Yung runway natin sa airport is very wide, right? Because you can land an airplane there, but it's not very long. That's just like a sample of a millimeter wave. But there are roads, like for example, the SCTEX, the Subic-Clark Tarlac Expressway. It's very long, okay? And that's sufficient, no, yung kanyang bandwidth. So we call it the mid-band. And there are roads also, or frequencies, that are very narrow, okay? Probably 2 lanes only, but it can go very far, no? From, like for example, from Batangas going to Quezon or Albay, no? So those are the low bands. So it cannot accommodate an airplane because of the bandwidth. It cannot accommodate 4 lanes, but 2 lanes is enough, but this very low. Okay? Do you get that analogy of frequency and roads? Okay. So when we talk about 5G, 5G is also one of the technologies, actually the first technology that uses a wide range of frequencies. You can see the 5G is operating at 300 megahertz, from 300 or 450 megahertz going to 90 gigahertz. Okay, so malaki yung ano niya, no? Malaki yung kanyang operating frequencies. So you can operate 5G in low frequencies, and also you can operate 5G in the high frequencies up to 90 gigahertz. Okay, but currently right now it's 28 gigahertz in the 3GPP standard. Unlike LTE, LTE is in the mid-range here, mid and low frequencies. GSM and 3G are also here. But unlike 5G, 5G extends up to this frequency. We call it the millimeter waves. Okay. So why it's important for us to have a selection of frequencies? Okay. Why it's important for us, especially if you're if you want to start a career in the radio network design and planning, this one is very important. This concept is very important. Okay, so especially if you're new or if you belong to a new operator that wants to decide which frequency to buy. Yan. So the RF engineers are the ones who help, no, in the frequency selection. Okay, so sometimes RF engineers become promoted and they become solution architects. So you have a side view of the site, okay? And then you have a top view, okay? I will show you the top view, okay? So if, for example, you're using a 2100 megahertz, so this is a typical example of the propagation. In terms of propagation, kung gaano kalayo yung nararating nung ating signal, if you're using the 2100 megahertz, okay? Now, comparing it to 700 megahertz in terms of the propagation, 700 megahertz travels longer, no? Propagates longer, okay, than 2100 megahertz. Okay. Now, if you have population, you can see that more population can be covered by the 700 megahertz, right? Because mas malayo nararating niya. But gusto ba natin mas malayo lagi nararating? Do we want to cover more people with 700 megahertz? There will be a problem. What will be the problem? If you cover a lot of people with a single cell site, what will be the problem? Can you type in? Overload? Yep. Capacity? Yes. Throughput, congestion, interference, right? So this is very important when you select a frequency. No, in the application, it's either run or open run. Okay, just imagine the difference only is the openness of the system. If you apply this concept to the traditional run, it's the same as like what we are doing in open run. In open run, we will just put intelligence in the network and we make the system open. Okay, but the concept of the frequency, propagation, penetration of the frequency is the same. Okay. Now, in terms of penetration, okay, so there are frequencies, higher frequencies get reflected from walls and have poor penetrations. So that is one of the behaviors of the high frequencies. And low frequencies get attenuated from wall but still penetrate. Okay? So ito yung advantage no nung low frequency over the high frequencies. But advantage of the high frequencies, most of the high frequencies, okay? Most of the high frequencies have a wider bandwidth. No, mas malalaki yung bandwidth niyan. So kapag malalaki yung bandwidth, meaning, no, it can accommodate a lot of traffic and capacity. So there is a trade-off na you need to balance. The trade-off of coverage and capacity. And then when you mix these two, there is another parameter that is coming, quality. Okay, the quality, because if your cell site is transmitting very far and then it causes interference to other cell sites. So even though meron kang capacity and coverage, the quality becomes very poor. So you need to balance it. Okay? Okay? Ayan. Okay, so lower frequency, signal travels farther. Lower frequency, fewer base stations because it travels farther, no? So we need few base stations, okay? And then higher frequency, bigger bandwidth, and then higher frequency, higher capacity. Okay? Ayan. So if we already know this concept of frequency, bandwidth, coverage, capacity, how do we apply it no, sa ating system? Okay, so let me share with you. Mamaya na yung carrier aggregation. Dito na tayo sa basic. Okay. Alright, no? Dito tayo. No? Say natin. So meron tayong cell site. We have a radio access network. You have this 28 gigahertz. Okay? That means 28,000 megahertz. So the capacity of this is the bandwidth is so big that the capacity or the throughput can go up to 5 gigabit per second. Okay? Okay, up to 5 gigabit per second. So ganyan kalaki no, yung ating capacity. But the coverage is very small because of the propagation and penetration. So where do we use it? So we will use this. I-deploy mo ba itong 28 gigahertz sa mga rural areas in which ang mga bahay is separated 1 kilometer from each other? Where do we deploy it? We will deploy it in the hotspot areas, right? So, especially sa mga cafes, sa mga offices, okay? And the concentration ng mga tao. Okay? Next, you have the 3500 megahertz, very famous no pagdating sa 5G deployment, especially here in the Philippines. Okay? So, this is good for urban capacity with massive MIMO. Okay? The wavelength is good enough for you to have 192 elements separated to each other. Okay? And the bandwidth is around 2 gigabit per second. Okay? So dahil sa kanyang bandwidth. And then if you have 700 megahertz in the pipeline, so it can go up to 200 Mbps or 0.2 gigabit per second. And it has wide area and deep indoor coverage. So which of the following can be deployed in some rural areas if you want to have an LTE or 5G, right? 700 megahertz. Now, if you're going to select a radio, an open run radio, and then you want to deploy it in rural areas, which frequency will you choose? Which frequency will you choose? And then you were using Open RAN, still 700 megahertz, right? So now you get my point. Regardless of is it open or closed system, in terms of the radio access network, frequency concept is the same. Okay, the spectrum concept is the same. Now, the 2 gigabit per second, is it really happening right now? Okay, the 2 gigabit per second, you can see this is a sample 5G test, done in Clark last time when we go outside, and then we try to do a speed test in a 5G network using a 3.5 gigahertz. What we got was 1011.97 Mbps, which is equivalent to 1 gigabit per second. Okay, so yan ang nagagawa ng bandwidth natin. Okay, ayan. Okay, so sir, kanina sabi mo the frequencies are wider, or the bandwidth are wider pagdating sa higher frequencies. So let's take a look at the frequency bands for 5G NR in the 3GPP release 16. So these are the operating frequencies under FR1. So we have two frequency ranges sa 5G. We have the FR1 and then we have the FR2. FR1 starts from 410 megahertz up to 7.125 gigahertz. This one. FR2 starts from 24.25 gigahertz up to 52.6 gigahertz. Now, let's see. Sir, tama ba yung sinasabi natin na kapag ka nasa higher frequency, mas mataas ang bandwidth, mas malaki ang bandwidth? So, let's see. Let's take a look itong frequency ng N1, band 1, 1920 to 1980. So, this is the frequency ng 2100 megahertz. Okay? So, if you check the bandwidth of this, anong bandwidth nito? 1920 to 1980. Anong bandwidth niyan? Can you type in? 60 megahertz, right? 60 megahertz. Siyempre, parehas yan. FDD yan, frequency division duplex. 60 megahertz. 1710 to 1785. This is the 1800 megahertz. Anong bandwidth nito? Only 75 megahertz. Ito is mga low frequencies, So ito, bumaba pa tayo. Let's take a look at the 800 megahertz, which is a low frequency. 824 to 849. How many? 25. So meaning the frequencies from 800 megahertz or 700 megahertz going to 2100 megahertz, it's not exceeding 100 megahertz. Wala siya, below 100 megahertz yung bandwidth niyan. Okay, so we can, and then you are not owning all of those frequencies, right? It is allocated to different operators pa. Now, let's take a look at the frequencies na nasa 3.5. Let's see, 3.5. Okay. Sa 3.5, ito, which is very famous in terms of the 5G NR NSA. 3.3 to 4.2. Kano kalaki yan? How big is the bandwidth there? 1,100 megahertz. Malaki ba yung bandwidth o hindi? Malaki ba yung bandwidth? Or 900 megahertz? Malaki ba yung bandwidth? Yes. If you look at that in terms of kalsada, ang lawak ng kalsada, laki ng kalsada, lawak. 900 megahertz bandwidth is very big. Okay. Now, let's take a look at the FDD, at the millimeter wave. Tignan niyo yung millimeter wave naman. Okay. So, sa millimeter wave tayo, narinig niyo na yan. Yung N257, 26,500 megahertz, and then 29,500 megahertz. Anong bandwidth nito? 3,000 megahertz. Right? 3,000 megahertz. That's why, kapag gumagamit tayo ng millimeter wave, okay, millimeter wave frequencies, and then na-allocate sa atin yung frequency nang wala tayong kaagaw na iba, no? Wala tayong kaagaw na iba, napakaswerte natin. We are very lucky, no? Umaabot siya ng 5 gigabit per second. Okay? Okay? You understand why? It's not because of the frequency. The capacity is not because of the frequency. The capacity is because of the bandwidth. Are you getting my point? So whenever someone asks you, why the 28 gigahertz has a bigger capacity? Because it has the bigger bandwidth, no, that we can use for the transmission. Okay? Are you getting my point? So it's not the frequency, it's the bandwidth. Actually, if we have a bigger bandwidth in the lower frequency, we can still achieve this. But the problem is we don't have that much in the lower frequencies. Okay? Okay. Are you getting my point in the concept of the frequencies and bandwidth? Okay, so that is for the capacity. Now, let's go. How wide is the coverage? No? So in physics, so we have this phenomenon about these frequencies, that low frequencies have less propagation loss than the high frequencies. So let me share with you a simple study, no, that I created. Okay. So this is a simulation comparison I created last time. So I have an suburban area. I have a suburban area which has a 2.7 kilometer by 3.2 kilometer. Okay, are you seeing this slide? Okay. Now I simulated a cell site with 20-meter antenna height, mechanical tilt. The antenna tilt is 2 degrees and the electrical tilt is also 2 degrees, and 4 sectors, so 0, 120, and 240. Okay. Okay. So this is the location of the cell site. It's in the middle of the suburban area. And then I used a frequency of 900 megahertz. I used a frequency of 900 megahertz, RF power of 20 watts, equivalent to 43 dBm. TRX is 444, 4 TRX, 4 transmitters each sector, and my remote radio unit is the back of the antenna. So if you will analyze this, you can see the blue color. These are the propagation of the 900 megahertz using the GSM technology. So you can see the negative 85. So just look at the blue color for those who are beginners in the simulation. So if you can see that the blue colors, we can say that the cell site, the GSM 900, is reaching up to 2.7 by 3.2 kilometers. So just by looking at these parameters, distance parameters, you can see if I use 900 megahertz, my GSM signal goes further. Mas malayo yung nakarating niya. Okay? But look what happened when I change the frequency of the same cell site. Probably just change the antenna also. Okay. With the GSM 1800. Same power, same TRX configuration, same radio remote unit location. Look what happened to the propagation. What happened to the propagation? Can you type in? What did you observe? What did you observe? No, lumiit, no? Reduced. It's because of the propagation loss. And not considering also yung penetration. Okay? It's only on the propagation. So that's why when 700 megahertz was opened for operators here in the Philippines, a lot of operators, most of the operators want to get that frequency because it's something like a golden frequency. Meaning, the propagation goes far and have a very good bandwidth. No? Ang gandang i-deploy nito, especially for rural areas. And then, in terms of CapEx requirement, meaning capital expenditure, when you try to build a cell site, you don't need to build a lot of cell sites. Like, for example, if I will build a cell site using 900 megahertz compared to 1800 megahertz. What do you think? How many G1800 do I need to have a same coverage as a 900? How many? Oh, probably 3, 5, or 2 if you're running out of budget, right? So meaning if, for example, this is only for example, if one cell site costs 1 million pesos, and then you need to build 3 cell sites, it will cost you around 3 million or 5 million. So what is 5 million versus 1 million, right? So it's a good cost savings. It's a good savings and a good investment if you have this low frequency in terms of propagation. Okay, but meaning even if you cover all of this population, okay, remember the concept of capacity, right? If you cover this population with only one cell site, what will happen? What will happen? It will congest, right? Good coverage or big coverage is not always good thing. So there is a parameter of capacity that we need to take care. That's why in some cell sites, you can see there is a 900 and there is also an 1800 layer. Okay, so you are combining different frequency layer to accommodate the capacity. Okay, yeah. Okay, so I hope this concept is clear with all of you. Okay, can I get a thumbs up again if this makes sense to you? Kung hindi siya ganong kalalim. Okay. All right. So we have a lot of frequencies used here in the Philippines. So we start from 450, 700, 850, 900, 1800, 1900, 20. So these are the different frequencies, right? And some frequencies are TDD and FDD. Okay. So when we say FDD, okay, when we say FDD, frequency division duplex, you have a separate frequency in the uplink and downlink. Okay, and then for TDD, you have one frequency, and then it's only separated by time. Okay, so there are frequencies na talagang naka-allocate, already allocated by the ITU to become TDD, and there are frequencies that are already FDD. Okay, yeah, so you can see here that there are frequencies that are FDD, and then there are also frequencies that are TDD. Okay. So in the case of the Philippines, if you check the frequency band of the Philippines, this is how it looks like based on the February 2020. I'm not sure if it's updated, but this is as of February 2020. Most of the frequencies are owned by Smart. Okay, 36% are owned by Smart, and followed by Globe, followed by Misatel way back then, but now we call it DITO, okay, telecommunications, and there are small operators owning part of the overall frequencies under the broadband wireless access frequency bands, okay. So we have the broadband everywhere, Altimax, Now Telecom, Multimedia, and there are some under litigations, okay. Okay, so I'll just run quickly now, no, para makita nyo rin yung mga frequencies. Like for example, for the N77 and N78 bands in the Philippines, from 3.3 gigahertz to 3.6. So there is an operator owning 100 megahertz, operator 60 megahertz, 20, 40, 20, and 60. So this is how the frequency of the 3.3 or the N77 to N78 is being allocated to each operator. Okay, so it's a 300 megahertz bandwidth. Malaki to, 300 megahertz. And the 300 megahertz bandwidth is allocated to different operators. Okay, so ito yung mga different operators. So you have the operator 3. Okay, you know this operator 3, the operator 1, the operator 4, the operator 2, and the operator 5. Okay, so you just have to decode who's this operator, no? Who owns these frequencies in the N77 and N78 bands. Okay, ayan. So we already familiar with the frequencies. Okay, with the frequencies. And then now we go with the DSS. No, I would like to introduce to you DSS frequencies. So why DSS is important? So dynamic spectrum sharing. Okay. So there is a motivation. Okay. So imagine again, there is a road or calzada, and in terms of the frequency, like for example, in the case of 900 megahertz, when it was first deployed here in the Philippines, it is used only in GSM 900. Okay, GSM technology. So just imagine one calzada, one road, it's used only by a certain technology. No other technology is allowed to use it. Okay. But right now, what happens to 900 megahertz is like this. Okay. The 900 megahertz, previously it's GSM only. Right now, what's happening to 900 megahertz is some of the frequency bands are the part of the frequency of the spectrum is used for UMTS or the 3G. Okay, that's why some GSM capacity has been reduced. Okay, and then may mga times na yung LTE or the 900 megahertz is used for the LTE frequencies. Okay, so we call it the frequency refarming. Okay, we call it the frequency refarming. So yes, the 900 megahertz can be used simultaneously for GSM, UMTS, and LTE. So it's just a matter of allocating the bandwidth to a certain technology. Okay, so if you have more frequencies or more bandwidth, you can use it to different frequencies, like different technologies like this. Okay. Now, maybe in the future, we can see NR or LT or 5G using this frequency, and then these technologies might be migrated to other frequencies. Okay, so this is how we separate the technologies in each frequency. So this is the type of spectrum sharing, but we call it the static spectrum sharing. Why static? Meaning, if you allocate one technology to a certain frequency, you will just fix it like that. Fix this frequency to this technology, and then this frequency to this technology, UMTS and LTE. Why don't we have a mechanism that can dynamically allocate the frequency bandwidth to occupy some part of this frequency if the users are not there or not using it? Probably the users are sleeping, and then a lot of users in the 5G demands a lot of bandwidth, so we can dynamically allocate this frequency like this. So some frequencies the UMTS, and then some frequencies are LTE. So that's the concept of dynamic spectrum sharing. So in case like this, that the roads are being congested already, but there are frequencies that are still free. If you are using a static approach, you cannot change it unless you change it manually. But if the system is intelligent enough and then can allocate these frequencies and allow these users to use this frequency, we call it dynamic spectrum sharing. Okay. And in the dynamic spectrum sharing also, you can see that the roads can be used by different technologies. So the technologies might be LTE or 5G. So the DSS is working only in the LTE and 5G because of the frame structure of these technologies. It's almost the same. So the frame structure, we'll just discuss it in the separate discussion, probably in the 5G, deeper topics on 5G. But the main concept is that we can use the same frequency, the same road with different, we can share the road with different technologies such as LTE and 5G. So what are the motivations? Hindi lang estudyante or board examinee ang merong motivation. Even the spectrum sharing have a motivation, right? So 5G NR can operate on low, mid, and high band spectrum for different coverage, capacity, and usage scenarios. We already seen this, right? That the 5G technology can operate on different kinds of frequencies. And then LTE LTE uses mid-band frequencies. Most of the time, it's 2100, okay, 1800 megahertz, or 850 or 900 megahertz. But most of the high band is on the 1800 and 2100. And new spectrum cost is high. New spectrum cost. Like for example, I will deploy a 5G system. And then I need, of course, I need the frequency, right? I need the road to let my buses go from point A to point B. I need the road. I need the frequency. So if I buy a new frequency, it would be costly. No? Mataas ang presyo niyan. Do you know how much? Do you have an idea how much the frequency of a spectrum or a bandwidth? Let's take a look at the NTC. Okay? So you're all familiar with the National Telecommunications Commission, right? So in the NTC, under NTC website, you just go here. It's a public document naman. You can see here. You can go to the info and then go to the, where is it? Rules and regulations, okay? And then memorandum circular. Okay, let's open the memorandum circular. Okay, so just a sample. Okay, so right now we have number of SIM registration as of yesterday, I think. Okay, but it's not our topic now. So I would like you to go to 2000. This is way back 2000, 2005. Go to the 2000, 2005, 2005, and then 2005, and then this one, rules and regulations on the allocation and assignment of 3G radio frequency bands. So this was the memorandum circular in 2005, where they released this one, a memorandum circular. I'm not sure if this was already amended, but let's just use for some reference only, just so that you have an idea how much is the frequency or the spectrum user's fee before an operator decides to buy or reuse a frequency. So this is based on the frequencies of 825 megahertz up to 2025 megahertz. So 1920 to 1980. So if you can see here, if you just scroll down on the spectrum users fee. Yep. So this is the spectrum users fee. So you can just read it, or just share the link, or just check it on your own. If you have time, just browse it. So if it's amended, it's 2021. How much was it? Just later, John. I will just check. So in 2005, it's first 5 megahertz. The spectrum user fee is 5 million per megahertz. Okay, so that's how expensive is it? It is, no? Yung ating megahertz, yung ating bandwidth in those frequency bands. And then if you exceed for the first 5 megahertz, it would be 8 million per megahertz. So if it's amended, how much na ngayon, John? So maybe John can share, kung na-amend na to. Yan. So umaabot siya ng 15 million per megahertz. Yan. So this is how if you have an idea, how the spectrum users fee way back in 2005. I'm not sure na ngayon kung magkano na. Okay? Ayan. So the spectrum cost is high. Hindi siya ganun kamura. It's not that cheap to operate. Okay? And let's see, Okay, so this is the new memorandum as shared by John. Hindi yata ito. 2.4 to dyan 2.4 megahertz to. Hindi to 3. Hindi to yung 2100 natin. It's a different frequency band. Okay. So it's a different frequency band, no? Spectrum users fee. Kasi ito is, I think it's a free frequencies natin, yung mga sa Wi-Fi frequencies natin. Pang point-to-point to. It's not the cellular type. So for the cellular type, it's different. Okay, but thank you, John, for sharing. Okay, so the spectrum cost is high. Okay, and acquire early advantage of 5G radio, which is 3 times the spectrum efficient than LTE. And opportunity to deploy 5G without refarming LTE frequencies or buying new spectrum. So if you can use your radio, your existing radio, using the same frequency, and then upgrade the technology to 5G, it's better. No, it's more cost efficient. And then it can also deploy in both standalone and non-standalone mode. Okay. So what is the concept of dynamic spectrum sharing? So when we say dynamic spectrum sharing is a key technology that dynamically allocates spectrum resources between LTE and 5G and are within the same frequency bands. So you don't need to change the radio. You don't need to change the frequencies or change the center frequency or operating frequency. The system will adjust, no, based on the actual network traffic. Like for example, if in this time you have a lot of LTE users, okay, so the system will allocate the whole band of frequencies in the LTE, okay, in the LTE. Okay, and then as the number of the LTE subscribers increases, so it dynamically allocate the frequencies to 5G or NR. Okay, so the spectrum is dynamically shared between the NR and LTE users. The base station dynamically changes spectrum allocation depending on the load and traffic demand for both technologies. Okay, so only software upgrade is needed for rollout for the traditional network. But for the ORAN, you can see that this is part of the ORAN technical priorities. So let's see a video how it is being done in the Samsung network, or how Samsung radio. Okay, so let me share this video to you.
Hi, I'm Donguri. I'm a principal engineer of 5G LAN system algorithm. Dynamic spectrum sharing is a technology that dynamically assigns resources to LTE and 5G, considering the traffic demands in the same spectrum. Most of all its benefit, DSS enables the smooth migration from LTE to 5G, while the refarming company is shutting down the existing technology. 5G interaction through DSS gives no impact on it, since it allows the coexistence of LTE and 5G at the same spectrum. In result, LTE users access to LTE and 5G users access to 5G accordingly, and operators can gradually change each network spectrum resource allocation according to the user traffic ratio. Another big advantage we can get from DSS is the easiness of coverage expansion. Since the new bands being utilized in 5G, such as mid-band and millimeter wave, have the smaller coverage than the lower band. So DSS can be the effective solution to secure additional NR coverage for densification. Furthermore, we can also think of aggregating low band and mid or high band. So the control signal goes to the low band and the data traffic goes to the mid band or high band. Hence, it results in boosting the throughput capacity while extending coverage simultaneously. Now, Samsung is actively discussing DSS deployment with a lot of global customers, and it gives operators more DSS deployment options by perfectly working on the virtualized platform. And also, Samsung DSS scheduler by making millisecond level scheduling decisions, it is promising the maximized spectrum utilization and performance. In addition, Samsung DSS can also flexibly interoperate with other FDD, mid-band TDD, and millimeter wave TDD for higher cell throughput and extended coverage by implementing the solution.
Ayan, no? So ito yung ating concept ng dynamic spectrum sharing. Okay? So instead of mag-refarm ka, instead of bumili ka ng bagong spectrum, okay? Instead na ganito gawin natin, no? Ang ginagawa kasi ng iba is nire-refarm nila yung frequency, no, ng LTE for those other operators without that much frequencies, no, or bandwidth. They refarm the LTE and then migrate it to 5G. But what most vendors around the world are proposing is that we can use a special radio that can operate in LTE and 5G and then dynamically allocate the frequencies, no, from LTE and R. Okay, and then you just you can still, no, maximize the spectrum. You can maximize your road, your kalsada, by allowing different technology to use it dynamically. Okay, it's not fixed on one technology only. Okay, I hope malinaw yung clear yung ating discussion ng dynamic spectrum sharing. Okay, so there are different approach in doing the dynamic spectrum sharing, but it will not be tackled in this topic because it's much on a deeper level. It's like using the MBSNF feature and the rate matching, okay, of how we do it technically in the system, no? Paano ginagawa, and then how we use the correct numerology of LTE and 5G, and then probably it will be discussed on the next sessions on the 5G on a deeper level. Okay, so yep, so yeah, one operator is using DSS and the 700 megahertz FDD. Okay, so let's move on sa Open RAN technical priorities by European operators. So this was shown to you in the ORAN use cases. Now we will take a look if the DSS is also part of the technical priorities of the European operators. Okay, so just a quick review on the ORAN architecture. So we have this Open RAN architecture. So basically what is being added here is the near real-time rate, and the SMO contains the non-real-time rate, and the following can be part of the existing or traditional RAN. Okay, so but the main difference, of course, is the system is open, the softwares are virtualized and powered by artificial intelligence. Okay, so you have the SMO, the near real-time rate, the OCU, UP, the ODU, the ORU, and the OCloud. Okay, so now let's take a look at the technical reference document. So the technical reference document says here, no, na in terms of the ORU, okay, the number of carriers, each band of the ORU must manage at least 4 carriers, okay, either LTE only or NR only or combination LTE plus NR. So these operators in Europe that agrees to have these technical priorities for Open RAN agrees, no, in the priority level and priority type that DSS must be part of the ORAN ORU specifications, okay, including in the outdoor and indoor. That's why the Open RAN and the dynamic spectrum sharing use cases is also discussed here in the Open RAN Academy, because Open RAN Academy. So because it is also part of the technical specifications, and then in the future we might be encountering this feature of the Open RAN network. Okay, so now let's take a look at the Open RAN and dynamic spectrum sharing. Okay, so this is a simplified architecture, no, ng isang Open RAN system using a dynamic spectrum sharing. So you have this SMO, the service management and orchestration, that contains a non-real-time RIC, okay, and then you have this RAP, which is the DSS application, and then it is connected to the non-real-time RIC, okay, which also contains this XApp in the DSS, and our CUDU Okay, this is the probably the baseband unit natin in LTE, and in 5G it is connected to the EPC or NG core. Okay, so ating LTE core or 5G core, and then we have the following towers, no, and then we have these frequencies, no. We have the X frequencies that we can have these shared frequencies between LTE and 5G, and we have a separate frequency for 5G. Okay, and of course there is a UE 4G only, and then there is a UE that is capable of DSS, and there are also UE that is only capable for 5G. Okay, so what is the goal? The goal is to enable operators to dynamically share spectrum in the existing 4G deployment with 5G systems based on the dynamic loads of both networks and resource sharing policies. So instead of using a different frequency, lalo na no, kung for example, ang frequency lang natin ngayon, for example, I'm operator A. And currently, ang aking frequency right now is only at 700 megahertz. That's the only frequency that I have. Or probably I have 900 megahertz, but I use it in the GSM and UMTS and LTE. And I also have 800 megahertz. Okay. But if I only have L700 and then I want to deploy 5G, okay, I want to deploy 5G and I don't have this 3.5 yet, no, 3.5 gigahertz yet, I can deploy 5G using my 700 megahertz. So what I will do? What I will do is that I will activate dynamic spectrum sharing in my system. Okay, meaning the LTE and the 5G will use my 700 megahertz dynamically. And since this point in time, probably I'm a new operator and I'm still checking how many users do I have in the network that are capable of 5G. Probably in time zero, when I deploy the DSS, most of my subscribers are operating or are using the LTE 700. And as the time goes by, dumadami, no? My subscribers are upgrading their system or their UEs, and they try to buy a 5G capable devices, and then suddenly dumarami, no, yung aking subscribers that are operating at 5G. So my system, my network dynamically adjusts, no, from LTE to 5G. It depends on the number of subscribers in the 5G, and it depends on the number of LTE subscribers. Okay, so the main actors in this role is the non-real-time rate. Okay, the non-real-time rate. It hosts the spectrum resource sharing policy. Non-real-time rate ito. Yung mga policy, no, nung operator. How much bandwidth or how much resources can be allocated on this certain point in time. No? Yeah. The near real-time rate, this one, executes resource sharing models coming from the non-real-time rate. So the artificial intelligence machine learning models created in the non-real-time rate. So last week, no, we discussed with Dr. Mel, no, Alipio, yung artificial intelligence machine learning. So this happens here. And then once the model is already configured, it will go down in the non-real-time rate. The non-real-time rate is the one that will execute these models and algorithms, translating the RAT policy to configuration. So the model will be executed by the non-real-time rate. It will go down as control, configuration, and data subscription over the E2 interface pagdating dito sa mga CU, DU natin. Just imagine the time that the optimization engineer tried to change the parameter, okay? Change the parameter and then send it to the OSS. No? So ganito ginagawa rin yan. It becomes this engineer. But this time it's artificial intelligence executed by the non-real-time rate. Okay? And the radio access network, this one, the radio access network executes the resource sharing enforcement. Okay, so once the near real-time rate sent the parameter or the configuration control, the RAN will execute it. And policies collects and reports RAN statistics and performance over the E2 and O1. Okay. So some preconditions before we apply it, the network must be, of course, operational. Okay. And the SMO has established the data collection, okay, and sharing interface with the non-real-time rate. Okay. And the non-real-time rate, of course, you analyzes the historical data from RAN. Okay. So kumukuha yan ng data sa RAN via O1 interface. Okay. And trains with the help of the SMO functions and deploys the relevant artificial intelligence and models going to the near real-time rate. Okay, so the operation begins when the operator, okay, for example, I'm an engineer in the operator A, specify the trigger condition or event detected. So what are the trigger conditions? So you are the one also. You're still the one that who will decide the trigger condition and the event that will trigger the execution of the dynamic spectrum sharing. So number one, the near real-time rate, okay, collects DSS related run function capabilities and configuration parameters from the run over the E2. So magko-collect tong near real-time rate, and then the non-real-time rate will communicate DSS relevant policies to the near real-time rate over the A1 interface. Mag-usap silang dalawa. And then the near real-time rate communicates this RAT specific DSS relevant configuration, control policies to the RAN over the E2 interface. And then the RAN deploys the configuration and control policies received from the near real-time rate over the E2 interface. Okay. And then after that, the near real-time rate will collect, no, may mga feedback and relevant observability data from the RAN. Okay. And then the RAN deploys the updated control policies received from the near real-time rate over the E2 interface. And then the non-real-time rate adjusts the policies, no, if there's a need to adjust, okay, based on the performance management data from the SMO and the feedback from the near real-time rate. Yeah. And then the non-real-time rate updates the resource sharing policy to the near real-time rate. And then the flow goes on, no? Yan. So paulit-ulit lang. So humihingi lang siya lagi ng feedback kung tama ba or maganda ba yung kanyang timpla ng mga parameters ng kanyang algorithms. Okay? Ayan. So ganun yung gumagana, no, yung ating dynamic spectrum sharing pagdating sa when it comes to Open RAN system. Okay? Ayan. So that ends, no, our discussion for today in the dynamic spectrum sharing and RAN, no. I just cut some topics but kasi we're running out of time. So here are the key learning points. So in a wireless telecommunication systems, the network is composed of three main parts: the core network, RAN, and the user terminals. And then the RAN uses electromagnetic energy in the form of the radio frequency to transmit and receive information from the network to the subscribers. And the spectrum is this fundamental asset that provides wireless connectivity. It is an invisible electromagnetic wave generated by the radio transmitting device. And the DSS, or the dynamic spectrum sharing, is a technology that dynamically allocates spectrum resources between the LTE and 5G NR within the same frequency band. And DSS is also part of the O-RAN use case to enable operators to adopt radio resource allocation policies and control to dynamically share radio spectrum between 4G and 5G networks. Yeah, okay. I hope may natutunan kayo ngayong araw. You learned something fundamental today. And yep, so we'll proceed with our Q&A questions. Q&A tayo. Does DSS works well with network offering slicing? If it's a standalone mode, yes, it will work. Most of the end-to-end network slicing will be offered in the standalone mode. Yeah. Okay. Next question is, hi sir, if DSS will be implemented, should there be a need of upgrade on the backhaul of the network? Thank you. if it's DSS, no, it will not most of the transmission kasi August have what do you call this, margin already. So as I see in the transmission planning, when they put this backhaul requirement, they still add up to 20% or 30% up. So there's a possibility that if you will go for DSS, minimum na lang yung yung ating augmentation in terms of the backhaul. But before we activate these DSS, we also inform the transmission team so that they can check the end-to-end bandwidth of the backhaul. Normally sila RF at sila engineering ang nagsasabi to the transmission team how much capacity will be added in terms of the radio side, so they can adjust in the transmission if needed. Does DSS work with NSA and SA? Yes, it works both on NSA and SA. Okay. Where can I get the feedback form? Yung feedback form is already here. Okay. So yan yung ating feedback form. Is that been checked? Does DSS affect the speed of network? Yan, from LTE to 5G since they use same bandwidth. Yeah. So that's why I'm showing always showing the concept of the road, right? So if a lot of subscribers are concentrating already or using the road, it will affect your throughput also. But of course, if you have less subscriber there, if you're using a higher technology and then sufficient pa yung bandwidth, your throughput will improve. Especially if you use the 5G technology. So it will improve some of the subscribers will improve, and then some networks experience yung pagbaba ng throughput in terms of the LTE, because previously the LTE subscribers are just alone in the frequency, right? And then suddenly merong mga 5G subscribers taking some chunks of the frequency or part of the road. So naapektuhan yung mga ibang LTE. Sir Richard, why is it that in the DSS architecture, one of the O1 interfaces is directly between the CU and the non-real-time RIC? And when in the standard or the O1 interface only between the non-real-time RIC, the DU. Let's see, no? Asan niyo siya sabi ni Sir D? This one. O1, tama to, sir, tama. Because the O1 interface is connected to the E2 nodes. So to get feedback. So the SMO is getting feedback from the non-real-time RIC and also from the radio access network. So para ma-process nila so they can process the data and then matrain yung artificial intelligence / machine learning. Maybe it was not completely written. Tingnan natin. Let's see. Here. You can see, here also in the ORAN architecture, there is a connection of the ODU and the ORU to O1. This one also. This one is a shortcut. O1 is connected to the near real-time RIC, to the OE node B, to OCU, and the OCP. It was not directly linked because it will become cluttered dun sa ating connections. But there's a connection of O1. There is an interface of O1 from the SMO going to the near real-time RIC and to the radio access parts. How about the capacity? It will be shared. Yes, the capacity will be shared. Actually, the frequency will be shared. Okay. And then how you use the frequency, it depends on the technology. We call it the spectrum efficiency, right? So like, for example, if you give 1 hertz to 5G and then 1 hertz to LTE, they will use it differently. That's why there's a difference in spectrum efficiency in terms of two technologies. What is the ICEP batch and number? Only if applicable. You don't need to put it, no, kung ano naman. Kasi that feedback form was used in the ICEP last time. So if you don't have a ICEP batch, you just put a random number siguro. But if you have the ICEP number or PRC license, you can just put something. Is it possible to get a high frequency signal to a higher coverage similar to what of lower frequencies? Higher. You want to have a higher frequency signal. So you're using, the question, Rinaldo, is to, can you get the same coverage? I'll simplify the question, Rinaldo. Can you get a high, the same coverage that the high signal and the low frequency signal can give, right? If you want to have the low frequency and the high frequency to have the same coverage. Okay. In terms of the link budget, technically you can do it, but it's not practical because you need more power. So what you just need to do, just check the link budget, check the path loss propagation difference, and then add it in the power of the transmitter or add it in the receiver sensitivity. So you can just do a balance, but it will not be practical. That's one. And then that's another one is the one that Carlo is mentioning, the SUL. But this is a different approach, no, to balance the budget, the link budget, the uplink and the downlink link budget. It's tanong ni Romel, maybe off topic, but what are common example of northbound interfaces of SMO in ORAN supporting orchestration and AI? It's not here, no? It's not here also sa ano kay sa link, pero not sure if I can pull out. Nakalimutan ko rin yung interfaces nila, no? I cannot sure if I can pull out this SMO going to these different elements. But maybe Romel, you can just send an email to me and then I'll just take a screenshot of that slide and then send it to you. Yeah. Okay. Okay, any more questions? Wala na ba tayong questions? All right, so I hope you learned something useful today.